It's been 3 weeks since the AIME 1 for this video to come out, and that is just due to the sheer production quality that is required for this video. I'd like to start off by thanking all my patrons. They are on the screen right now. Alright, let's start with the video. So, we have like two people, Melanie and Sherry. So that's Melanie. Wait, no, that's not Melanie. Screw it, whatever. It doesn't matter. So we have Melanie and Sherry, and they both have to swim to this point here, because that's a special point, and they do. They both swim here, but the problem is there's a current. So in actuality, this person right here, regardless of what their name is, they actually have to sort of aim right here, because the current is gonna push them the rest of the way so that they get here. And similarly, this person here is also gonna have to aim right here, since the current's gonna push the current's gonna do the rest of the work. So let's look at this point then, because the current's kind of annoying, so we want to ignore it. So if there was no current, this is a mess of arrows right now, so I'm gonna get rid of some of these arrows. Okay, so this is a point that they both aim at when they're swimming. It's just so to account for the current. So then what's this distance? Well, we need a new variable to account for that, and that's how long they swim for. Because however long they swim for, it's also how long the river pushes for. The river pushes for m, so let's say the river pushes for m minutes, then it flows 14 m meters in total. So then this distance would be 14 m, since they're aiming 14 m meters, so they get pushed 14 m meters to the right while they're swimming, so they both aim right here. Okay. So they both aim here, and that's 14 m. And now we have a geometry problem. Since we also know what these lengths are, this is 60 m, and this is 80 m. So we can draw a sketch without all the beautiful art, even though that is beautiful art. So let's draw it right here. Wait, shoot, that's ugly. Okay. So now we're gonna draw some stuff. So this is where this is the first path. This represents this arrow here, and then this is the second path, and it represents this arrow over here. So this is like the paths they swim in. And this is the river. This is this corner is where the first person starts, and this corner is where the second person starts. So this is where they meet up in actuality, and this is where they meet up in our alternate reality. So we have that this is 14 m, as we established right here. This whole thing, as defined by the problem, is d, and we know this is 264 meters wide. So this is 264. And this is rectangle, since we're told the river is straight. In addition, that means that this is a right angle. So now it's time to pull out Pythagorean theorem. So we know that this is d over 2 minus 14m, and this is d over 2 plus 14m. So pulling out the Pythagorean theorem on these two triangles, we have two equations. Our first equation is 264 squared plus, this is beautiful handwriting, I know, minus 14m squared is equal to, we know, oh sorry, I forgot to add this. We know this is 60m, since we're told that the one person swims at 60 meters per second. 60 meters per minute. That's really fast. Okay, 60 meters per minute. So after m minutes, they swim 60 m meters, and then this person swims 80 m for similar reasons. So just remember, m is not meters here; it's a variable. That's great variable naming choices. And this is equal to 3,600 m squared. And then similarly on this on the right triangle, we have two on like the east, right, like, yeah, okay, you get it. And then 264 squared plus d over 2. No, you don't get it. You don't get it. Okay. Because you can't read my handwriting right now because it's too good for you to read. Is equal to 6,400 meters squared. Okay, so I mean, the 264 squared is pretty terrifying. So let's get rid of it by subtracting the first equation from the second equation. Just like how I got rid of all my problems. Okay, so 2,800 m squared Actually, I still have problems. My handwriting sucks. Okay, so d over 2 add 14m squared. We get d over 4, d squared over 4 add 196m squared, and that also comes on this this expression. So those cancel out. But we also have a 14md here, and we have a negative 14md there. So when we subtract negative 14md from 14md, we get 28md. Okay, so we get this equation. And then we can divide stuff. So dividing 28m from both sides, we get that d is equal to 100m. Okay, so now let's do stuff. So what we're gonna do is we're gonna substitute this back into these equations, and now we have that 264 squared plus. We don't need the second equation anymore. So now we have that 264 squared plus 50m minus 14m, which is 36m squared, is equal to 3600m squared. And now if we subtract 36m squared from both sides, we get that 264 squared is equal to m squared times, we can factor an m squared out of the right hand side now, 3600 minus 36 squared. Alright, and now we can use difference of squares to simplify our calculations for this. I see you can't really tell between sixes and zeros. For like the 50th time in this video, my handwriting sucks. So 96, this is equal to 96 times 24 by difference of squares. So if we divide both sides by 24, actually, if we divide both sides by 24 squared, we get that 11 squared. I should probably, okay. We get that 11 squared is equal to m squared, 4m squared. So therefore, m squared equals 121 over 4. So m is equal to 11 over 2. And now let's look back at this. So therefore d is equal to 1100 over 2, which is equal to our final answer of 550. Yay! Okay. Bye. Chicken nuggets. Your mom. Haha, get right.